Good morning all. I am being swamped by an ever-growing pile of post, so I think it's time for another post bag. So shall we do just the yellow ones? Yeah, why not? So this one is LED module. Let's see what it actually is. A couple of packs and a charge cable. Right, this one is... oh, it's got a sticky out bit of wire. I've got a feeling this is a battery capacity checker. And I think what you do is you attach the resistor, what's that, 5 watt, 8 ohms, 8.2 ohms. I think you put the resistor across a couple of these terminals and the battery, and then this thing just watches the battery discharge into the resistor and measures amp hours, amps, volts, and that sort of thing. Interesting. I'll take a look at that on eBay. So this is it on eBay. It's a 1.2 to 12 volt battery capacity tester, external load discharge capacity test, 18650, $6.95, free shipping. This came from Yukon 2015. Now I've just noticed that my resistor is 8R2 and the one on the photograph here is 7.5 ohms. So is there somewhere in the menu setting of this thing where you actually set the resistance value, or have they just thrown in a roughly equal resistor and I'm going to get hopelessly inaccurate results? I don't know. Power supply voltage 4.5 to 6, so that's on the micro USB, so that's why they threw in that cable. So I can power this up right now. Working current less than 70 milliamps, mostly for the LED displays, I would imagine. Discharge voltage 1 volt to 15 volt. I think that's probably the lower end of the voltage where the thing stops. Resolution is 0.01 volts. Termination voltage range, oh no, this is the termination voltage range. 0.5 volts to 11 volts. Oh, there's lots of detail here actually, so lots of opportunity for reading, including error messages and this, that and the other. I better get reading. So from the eBay photo, it looked like the resistor goes on the outer two connections, and in fact on the back you've got R and R, so yes, that's where the resistor goes. In here is presumably the battery under test. Well, I can power this up now from a little power bank, so perhaps I'll do that. I'll fit the resistor and power this up. So I'll put this in with quite long leads initially, and then if that doesn't feel right, I'll cut this down later on, but I don't want to cut it short and then find that there's an unforeseen issue. So that's the resistor on the outer two, battery on the inner two. Right, let's power this up now with USB. Oh, I've got a feeling my nephew flattened this the other day because he was charging his vaping thing. I'll have to find another one. Right, this one seems to have some juice in it, so let's plug that in. Okay, that did a brief self-test on the LEDs. That's now lit up. Now, what's that telling me? 0.06 volts. Well, is that the measurement across these inner two terminals? Because if it is, it's not very accurate, is it? I'll just do some reading on the instructions. Note, this circuit, in order to improve the voltage measurement accuracy, specially designed DC bias when the terminal is what all don't pick will display a small voltage. Does not affect the actual measurement. If you are short connected with the input terminal, absolute 0 volt will display 0. To understand the principle, can consult the superposition theorem in electrical engineering. Well, I could try shorting those inner two connections, I suppose. So, a piece of wire, shove that across the... oh yeah, that does remove the DC offset, so I don't quite understand why they've put a DC bias on there, but They say they have, and indeed they have. So I'm just going to hook up a AA cell holder. So this is in plus, I've just checked. And oh, that's not tight, that's the wrong screwdriver. Ah! Now it says make sure the battery is fully charged. Well, I don't know, it's probably mostly charged. Oh God, I hate these stupid, I don't know, curved in sections that make it almost impossible to get the cell in there. Ah, okay, 1.33 volts. So, what do? Press go? Go! Power. Is that? Oh no, that's some sort of setting thing. I don't know what I'm doing! Well, it says you have to set the termination voltage to start with, and that is P. Why is P the termination voltage? And you can go up and down. What's the minimum? Oh, 0.5. Well, that's interesting. Well, let's take this down to 0.1. No, 1.0. It's about 1.3 at the moment. And then, OK to start. Flashes. Amp hours, 0. Amps, 0.157. Volts, 1.27. No amp hours yet. 0.156 amps. I suppose it doesn't really matter what this resistor is. Is that getting warm? Because it will measure the amps, it seems to be able to measure current and voltage, and therefore work out amp hours, and so on. 1.27, that's not dropping particularly quickly. But I'd like to see it clock up some... Oh, it has. 1 milliamp hour, I think that is. 0.001, yeah, so 1 milliamp hour, so that's quite a gentle discharge. So it's only 155 milliamps discharge. Of course it would be at that voltage. Now the thing about this is it's not going to be constant current, because as the voltage drops, this is a fixed resistive load, so as the voltage drops the current will also drop, won't it? Yeah, fixed resistor, V equals IR and all that. Yeah, well that certainly seems to be working. So it's a sort of cheap, quick, dirty, well not quick actually, quite slow, battery tester. Well, I think I might leave that on for a while. Now I can interrupt it by pressing one of these buttons. Now does it remember the data? No. It resets the amp hours, so it forgets the data if you do that. But what I can do is I'm going to force an error now. It's 1.31 volts. I'm going to set the end voltage to 1.5. And it should say that's an error because the cell voltage is already below your set termination voltage. So that comes up error 2. What's that on the battery voltage is lower than the setting voltage termination. Woohoo! Now there's also error 1. The battery voltage is higher than 15 volts. We've got this one lower than the termination one. Error 3, the battery is unable to withstand the low discharge current resistance is too large or line. Error 4, the current is too large, current is more than 3.1 amps. 2 calibration operation. Operation after self-calibration represents give warranty. At the same time, press 3 keys till the tester is energized. So press and hold all 3 keys, presumably. Enter the calibration mode. Oh, all that stuff. I just move the camera across. I'll just move the camera out and across, so anyone who wants to read all that can. So, I don't know, I'm quite liking this. It's nice and simple. There's no complications. There is a calibration procedure if you want to get into that. Let's just look at some of these components because they're actually marked on the board. I'll get in really close. So there's a 1117 there, so that's a 3-terminal regulator to take the 5 volts down to, oh, I don't know, 3.3 is it? There's an 8205. Now that chip is a MOSFET. That's often used, actually it might be a dual MOSFET, that's often used in conjunction with the DW01 cell protection IC. The 8205 is just the MOSFET for switching, so that presumably switches the battery into the load. I think I remember seeing one of these links was bridged, so probably the positive and the resistor is already bridged, and then this MOSFET switches the negative of the battery down into the resistor to turn it on. So yes, that's switching the load on. 3, 2, 1. Is that some sort of op amp, perhaps? Right, moving on. This was in the same package, and it is a power bank, and it looks like quite a nice one because it's by this Tease brand, and I have enjoyed their power banks in the past. Oh, that's all sealed. So yes, this is another Tease power bank, and this has an amazing textured surface with all these little squares that reflect light in different ways. It's also got this rather elaborate locking mechanism for the door hatch. Now, I seem to remember this was fairly expensive because I think the display shows you quite a lot of stuff. So let's get a cell in there. This is not my best cell. Oh, I was about to put that in back to front, I think. This one only measured 1500 milliamp hours, so positive to positive. Let's put that in because I just want to sort of see what this does. Oh, have I done that wrong? Okay, how do I get this display to come on? Now, oh, crikey. That's not good. Oh, I put it in the wrong way around. And smoke's coming out. I wonder if it'll still work. Well, despite the fact that smoke is still coming out of the USB sockets, the display is actually lit up. It's not very bright, but it is lit up. Now I think it's not showing as very bright because the camera is being affected by all this white, so let's get in a bit closer so we can see what's on the display. Well, I've blown this up. This is really embarrassing because sometimes it sort of comes on and sometimes it doesn't. I've cooked this. Sometimes I get that light to come on, sometimes I can't. That's really bad that I put the cell in the wrong way round. This is not a cheap power bank. Now it's doing a sort of alternate lamp flashing and display coming on thing. What's that? No, it's some reflection. Oh, I think it's a reflection of this lamp up onto my camera and back down onto there. But yeah, that's not working at all well now. Now, is this fixable, I wonder? I mean, what would have burnt out with reverse polarity? Something semiconductorish, probably. I think I'm going to have to open this up at some point and try and work out what I've done. Oh, well, I'm going to abandon this one. Well, no, I'll look at the eBay listing for this, but yeah, it's broke. And this was expensive. Damn it. So this is a 5-volt 2-amp LCD USB mobile universal power bank box rechargeable 18650 battery charger. $21.69 free shipping. This was from Yukon 2015, and I've burnt it. Let's just have a look at this image because that shows the display. High contrast display, easy to read. Yeah, possibly easy to read, not so easy to get a good picture of on the camera. Okay, so what are the various things? I'm just going to move the camera a bit because there's an icon right in the way. Voltage reading on the top left, current reading bottom left, time or battery capacity, need calibration when first time use. Remaining time is up there, and then this one shows you which ports are enabled, 1 and 2. Now in the description in red it says note battery is not included. What it doesn't say is not reverse polarity protected. I suppose it was fairly obvious it wouldn't be reverse polarity protected. So what are the features? Charge and discharge at the same time, so it has a pass-through USB type mode. Pity I can't test that now. Can use 5-volt 3-amp DC, 4.0 times 1.7 adapter, not sure what that is, to charge power bank quickly. Battery can be replaced. Full information LCD, displays current, voltage, capacity, time, maximum 5 volt, 4.2 output, 4.2 amps, 2 USBs at the same time. Yes, one is 2.4 and the other is 1.8. So yeah, that does add up to 4.2 amps. Special material cover. Yeah, that's the thing with the little squares. And compact design. Yes, it is quite compact. The battery is fitted in quite neatly. Capacity 10,000 to 20,000, depending on the batteries you put in. Lithium ion. Input DC 5 volt 1 to 3 amp. Output DC 5 volt 1.7 amp to 2.4 amps. Adjust automatically, so it must have auto sensing ports. Blah blah blah. But nothing about not protected against reverse polarity. So, want to see what cooked? Well, that definitely cooked. It's got a very large blister on top of it. This looks like it's probably a MOSFET for switching. Or is it? I'm not quite sure why that would cook because of reverse polarity. Let's get in a bit closer. So, yes, this device here cooked well and truly. Yeah, that's very much fried, but the one next to it didn't seem to cook at all, so maybe, I can't quite work out what's going on the circuit. Well, certainly this is the negative battery connection. So this is one of the devices that would feed the negative battery connection into the remainder of the circuit, but there are two separate of those. I can't quite see what they are at the moment, the markings on it. This one particularly difficult now because it's fried. But it also looks like this switch possibly got a bit hot. Now, is that the on-off switch? No, I don't think it is. I think that's the reset switch. So why would that get hot? It just looks a little bit blistered on the surface. I don't know. And I'm also going by the evidence inside here where there's a heat mark there. Right adjacent to the hole, let's refocus the camera. Yeah, right adjacent to the hole where that switch sits, some distance away, is it from there? I can't quite work it out. There's another heat mark just down here, but the main one's up here, which looks like where that switch is, which is a bit odd. Now this one that just says 358, I mean, is that just simply an LM358? Yeah, I guess it could be. The main processor is a PIC. It's a PIC 16F1946. There's another 358 there. I'm not sure about LM358. I think these might be MOSFETs. Yes, I've got a feeling they are, because you can see all four of the connections on one side are common. So that's probably a MOSFET. This is another MOSFET. These will be the MOSFET, the switching MOSFETs to switch on the two USB outputs. This is probably protection IC for the lithium cells for when they get too low voltage, when they go under volt. That's what I'm guessing. Right, you may just be able to see that that is a DW01, so that's the cell protection IC. There, that 6-pin SOT23 device. And this is a 2810A. So is this some sort of more advanced MOSFET than the 8205? I'm going to look that up, 2810A. Now this other one I'm not sure is a 2810A because it looks like it's the other way round. The lettering is the other way round. Looks like you can just see the remains of some lettering there. And also you can see that the index dot is on the opposite corner from that index dot. So possibly one of these is N channel and one of them's P channel. So this isn't a 2810A, this is, well, I don't know, it looks like a sort of 638, something 638. If I look up the 2810A, there may be some information on its opposite number, possibly. Let's look that up. Well, I can't find data on either of these two devices. This one looks like it might be something like a 91533, although it's very hard to see because it's all burnt. But I can't find anything on the 2810A. I'm back to thinking that these devices here are LM358s, because why would a MOSFET have so much resistors and capacitors around it? Both of these have a lot of R's and C's around them, and in fact it's not connected all 4 pins to the same place. I've looked more closely at this one down here and they all go to different places. So yeah, I think these are LM358s. Now on the other side, we have of course the display. That's backlit with an LED. Now these two chips here are 888, and those are the automatic control chips for the 2 center pins on USB, in order to negotiate with whatever you plug in to try and maximize current. So these are the auto sensing chips for USB. There's a little controller down here right next to USB in. This could possibly be a buck converter. There will have to be a boost converter here somewhere. It's probably this thing here. Let's have a look at the number on this chip. Well, that's an AXV588 or possibly 58B. Let's have a look at that one, AXV58B. Well, I can't find anything on that chip either. And this is becoming increasingly a problem, actually. The chips are so new and there are so many different ones coming from different manufacturers. It's getting harder and harder to find data sheets on them. But anyway, I think that's about as far as I can go with this. It's relatively straightforward. But one thing I can say for absolute certain is that this is not reverse polarity protected against some numpty putting the cells in the wrong way around. Now I'm thinking that the pretty much the only thing I can do to remedy this situation is to buy another one of these, which does seem rather an extreme solution, but then possibly you need an extreme solution to make up for the extreme stupidity of putting the cell in back to front. I've done it before, but I put the last cell in back to front, so there were already cells in there, and of course the last one just burnt through the spring. But to put the first cell in back to front is really incredibly cretinous. So, top clips on, and then the remainder are these 6 screws, 2 of which are slightly lower profile, which are the ones that go in the middle. But that's just no good, is it? Broken! So I think I'm going to call it a day, because I've blown up a $20, $21 power bank, which was incredibly stupid. And I'm not sure I should really carry on in case I blow anything else up. So an afternoon of extreme self-flagellation maybe. But for the moment, that's it. Those are today's Postbag items. Cheerio!